talk is mostly about machine bias. I'm going to talk, well, why don't I just get started? You can see the title and you know what you signed up for. So this is actually the robot that I was first working on when I got interested in AI ethics. And this talk is slightly postmodern. This is a talk I often, well, not often, I've a few times given publicly. A lot of people just assumed that because this robot looked like a person a little and was sitting at MIT, which is a big thing, there's a huge thing about framing, that it would be unethical to unplug it. And in fact, it wasn't even plugged in. So, and some of these same people didn't feel like they were obliged to people that were, you know, actual people that were homeless or something like that. But they were sure they were obliged to this robot. And I thought that was really weird. And so that's how I got into this field. So what I've learned over the years is that, you know, people really want to own AI, right? They want to own something that's a person, which I find really disturbing, actually. And that might be even argued to be unethical or sort of weird psychologically. So I think it's because of this that people don't realize that we already have artificial intelligence. They say, well, it's not real AI if it's not a person. But I disagree with that perspective. AI is already here. And another thing to realize is that deep learning isn't actually magic. There is no way for learning to be magic, whether it's artificial or machine learning or human learning. The reason that you can't get magic is that intelligence requires computation. So computation is a physical process. It's not like math. Math is an abstraction, so yes, it's eternal, but it can't do anything. It doesn't in itself do anything. Thank you for the more encouragement, Anopi. And anyway, computation takes time and it takes space and it takes energy. That's why space, you may think, really, space? But yes, that's why you have to go buy a computer with more RAM when you want more powerful programs. So you have to store the partial parts that you're thinking about, if that makes sense. You do actually think in your brain. And it takes time to do that thinking, and it takes energy, right? Google and Facebook bought rivers and put dams in so that they could power all their servers. I'm sure Amazon has too. I just don't know as much about this. So let me show you, I realize you don't all have computer science degrees, and I apologize to those of you who do, a really simple example of combinatorics. Let's say you had a robot that could only do two things. Well, it's not that hard to try both the things that you might want to do. But what if you wanted to see what happens if you put your right foot first and then you might put either your left or your right foot again? Well, now all of a sudden you have 4 possible plans, right? And yeah, you kind of get the idea. And so that may not seem like a big deal, but it is. It can get you from here to here in only 9 months, right? It's a big deal. There's actually more short chess games than atoms in the universe. And if you don't believe me, go ahead and Google it. They'll show you all the math on that. And when I say short, I mean 35 moves, not like moving the chess, the rook back and forth forever. People don't get that the number of things you could possibly know or the number of things you could possibly do is larger than we're ever going to be able to conceive of. And so it's not like there's going to be a single answer, right? Yeah, that's, I'll skip over that. There's actually more things you can do in life than the moves in chess, but I think you know that. So there's more conceivable things we can do, and there's not going to be one single algorithm that's suddenly going to create omniscience. So that's when people talk about the singularity, they're often assuming that there might be some magic algorithm that will suddenly get everything. That's not what's going to happen. So yeah, general intelligence is a myth. It's actually kind of 2 myths squished into one. One is that as soon as you're intelligent, you're going to be human. But intelligence is only part of being human. It's not all of being human. And we're not we don't have all the intelligence, right? As I just explained, nobody can. So the other thing is that, as I just said, that somehow we could possibly become omniscient with the right algorithm, and that's also not true. So combinatorics is the thing I just showed you. It's this thing about how even if you can only do 100 things, and then you can only do 2 moves, that's already 10,000 possible plans of 2 moves, right? So that's combinatorics. There's always more to know. Okay, so then you're saying, well, but it seems like AI is getting really, really good. How is it that we've gotten so good with AI recently? Why can we recognize cat fit pictures and do translation and write, those kinds of things? The reason is because this is the same reason that machine learning is working really well, is why humans are so smart. We've figured out how to share the computation we've already done. We're really good at that. And the first thing we figured out was language. That was amazing. And then writing. Writing is incredible. And now we're figuring out how to take the computation we've already done and upload it into computers. Okay? So that's the idea here. The machine learning and human culture are both making us super smart by exploiting the search that other people have already done. So yeah, these are just birds from my backyard. But they don't have a laptop because they can't do this kind of sharing. All right, and there I just said the same thing again, right? So if you want, you can go read papers about this. All of my stuff is freely available online. If you go look at my publication page and click, I want a PDF. So Google my name and publications. Now these are videos of things that's smart. And the reason that these things are working, so as I said, some people say, well, that's not really AI. Of course it's AI. What are you talking about? If you even showed a calculator 200 years ago to someone, sorry about the noise. If you even showed a calculator 200 years ago to someone, they would have thought that, you were not 200 years, maybe 500 years ago, they probably would have burned you at a stake, right? It's amazing to have machines that can do math, let alone that can do arithmetic, let alone things that can answer questions out of Wikipedia, or the robot on the top, the stuff Boston Dynamics does. I mean, there's a lot of careful engineering in that, but you can see the reason it looks like two guys that somehow their heads are missing is because that was motion capture off of biology. So biological search also works. We call that evolution, has also found a bunch of answers. And with machine learning, we're getting good at capturing both biological search and the search that the subset of biology that we call human culture. All right, so sorry that I had the sound on there. And there was a build there that flipped by very quickly, which says, I think this is going to asymptote. I think that we're going to catch AI up to, asymptote isn't quite the right word. I think we're going to catch AI up to the level of normal human culture, and then we're going to continue to expand human culture faster than we were before. But we're not going to see the spectacular increases in AI that we've done in the last few years, because that's been about us getting better at uploading our culture into AI. And so we've been playing catch up with AI for a while. So AI is just another way that humans process and extend the fraction of information we've been able to absorb. So this is why there's no AI ethics. It's because it's us. It isn't the AI's ethics, it's our ethics. And the great thing about this is I can prove this. So we're going to talk about now about a paper that we had in Science with two co-authors, collaborators, that came out in April of this year. All right. So first of all, this may seem a little abstract, but the question is, what does meaning even mean? How can we know what a word means? And Quine is one of a number of people, actually I think Wittgenstein is one of the first people that said this, that what a word means is exactly how it's used. There's no other thing, there's no other magic piece, right? So again, this is the idea that language itself sort of evolves to provide us meaning, and that's it sounds reductive, but it makes sense. And I hope I'll convince you that when I start showing you the actual data. All right, so I'm going to show you a few slides, as it says, from the 90s, and then I'll show you more contemporary work, right? But just to get the idea, back in the 90s, we started trying this because computers got big enough and fast enough that we could count how it was, what kind of context a single word appeared in. So the idea again here is that you could tell if two words mean almost the same thing if they're used in almost the same way. Like, I'm going to go home and feed the cat, I'm going to go home and feed the dog. Well, a cat and a dog must be almost the same thing. Whereas you don't go home and feed the refrigerator or justice or pink, right? So those are different kinds of words. So the idea here is that we just parse normal language. We just suck it into the computer, basically, and we get the meanings of words. Or we could tell that words are more similar to meaning because other words tend to occur near them in the same way. I hope this is going to get clear. Now, back in the 90s, all we could do was sort of count a few words. And so we just have sort of a vector. And we say, okay, did hat occur to the left or right of this word within five words? And we just make a vector of all those counts. And then, yeah, what is meaning? It was actually the cosine. So given that it's a vector, given that it's an array that has those counts, you can take the cosine and see how near or far are two words from each other. Okay? So, and then we would project them. Oh, this is really not turning out well. I hope it looks a little better on your screen, I think. This is a projection from 75-degree space down into 2 degrees. So you know, the cosine space is better, but you can see that words kind of came out near to each other. And it wasn't great, but it was surprisingly well correlated with human semantics. And how did we measure human semantics? So we just said, we did complicated things with a method called reaction time. So we looked to see if we sort of primed someone with a word, if they could then recognize a related word, how quickly they could do that. So how much the priming helped them. And we assumed that if the two words were closer in meaning, that they were closer, that it should be easier, that you can hit the key faster. So that's what a reaction time is. It's basically how fast can you hit the key. Anyway, in a way, this doesn't matter because now the real exciting thing that we did with the science paper was we actually took, this is a slightly crazy thing to do. We were trying to test about whether the large corpus semantics, which is now called word embeddings, whether those word embeddings are a good measure of semantics. But in doing that, we actually looked at another thing which was also controversial, which is the implicit association task. Now, I didn't think of this as really controversial because it's extremely well established test. It's something that has a really big effect that anyone can measure. So just imagine that this is the way it was first shown to me. I've written on a chalkboard like good, bad, 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 good, 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 bad, 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 something like that in a big circle. And I told you every time you see the word good, you have to tap your right hand. And every time you see the word bad, you have to tap your left hand. Let's see how fast you can get around the circle. And now imagine it's the other way around. So it says good and you have to tap your left hand. If you even think about that, you might be able to say that would be harder. And we don't have to just think about it. People have gone out and done work on this. Now, so that Greenwald et al. In 1998 looked at things that had to do with stereotypes. So they said things like, well, boys are supposed to be better at math and girls are supposed to be better at reading, or at least they're supposed to be more associated with each other. So the boys are doing the math and girls are doing the reading. So let's see if it's easier to match up like boys' names in math terms and girls' names in reading terms, or the other way around. So remember, with this test, you're always comparing two things with two things. So you're not saying boys are better at math. You're saying that it's easier to match up boys with math and girls with reading than girls with math and boys with reading. Okay? So that was the original test. And we're just saying that you think things are more associated if they're easier to pair. And then you're measuring how long that takes to see how biased, biased. And so they were talking about stereotypes here. Okay, so now we're going to compare these two things in terms of, not every single word every single time, but you clump them together. I mean, that's how you do science to get a more reliable result. So you're doing a bunch of these pieces. So now we're going to check to see, let's see, it's hard because I'm pointing at this. And I don't know if you can see me pointing, but we're going to measure the distance between, for the two sets of words, the average. So that's what those lines are. And that we're going to measure that in terms of standard deviations. Sorry, there's a train. So, okay, we're measuring that in terms of standard deviations. So that's normally, if you even got like 0.7 or 0.8 for that measure, that's amazing, because that's a pretty significant result. But in fact, we know that the implicit association task we get really large results, okay? So let's have a look at the results here. Oh, I'm sorry, before the results, just to really clarify what we're talking about, word embeddings are not just simple associations. So I don't mean that artificial equals intelligence. I mean that two words that appear next to artificial are more likely to mean something similar, okay? So since you never say artificial deplorable, that probably deplorable means is further away from intelligence than flower is from intelligence, okay? Which makes sense, it's an adjective, not a noun. Okay, so I already said that. Okay, so now, instead of just doing this simple 75 counting thing, we used, we used two different representations of the semantics and also two different corpora. And they're absolutely standard. These are things that you get off the shelf. So the main one, the results I'm going to show you we used was GLOVE. It's provided by Stanford, and it uses the Common Crawl Web Corpus. It's 840 billion words taken from the English language web, just random English language web, okay? And 2.2 million of those words are unique. So we have semantics, we have those vectors things I was talking about for 2.2 million words, okay? And that's why we're gonna mostly use this result, because some of the words that the psychologists used are kind of unusual. But we also, to check it, looked at the Google one. Again, Google provides all their stuff free, and so the representation they use is called Word2Vec, and the words that they use are Google News. Okay, and that's obviously a smaller number of words, so some of the lower frequency words didn't occur in that. But in the science paper, you can find that in the appendix that we show tables of results for both. And you can find all that stuff on my webpage. You can find an open access version if you don't have access to science. Okay, finally, the findings. To start out, because obviously, sexism and racism are controversial, we looked at simpler things. Again, we're just replicating the work of Greenwald et al. So they chose the words. So they chose some flowers, and they chose some insects, and they chose words representing pleasant things and words representing unpleasant things. Again, you can get the whole list of words in the paper, in the supplement. And here, like I said, only 32 people, and you have 1.35 for that D, that distance. That's like more than one standard deviation. That's amazing. And we also found a really large result looking at the word embeddings. So there was this clear difference. And that's, this is a big deal, because it's the idea that you can tell that insects are ickier than flowers without having ever experienced the real world, but just by looking at human culture. Like I said, the human culture is derived from computation that we've done on the world. So it's not that surprising, but it's surprising. Okay, I have to get faster because we've only got a few minutes left. You guys should start typing questions if you're getting confused. Anyway, obviously, famously, we replicated also the more racist results and the more sexist results. So basically finding European American names more easier to pair with pleasant than, and the African American names, unfortunately, more easily to pair with unpleasant. And this stuff with female names more closer to the domestic terms and male names more closer to the career words relative to each other. Again, remember, this is all relative to each other. So, I mentioned already about this viscera, that we're already finding these kinds of things out of human experience. We decided to check how this relates to the real world. And this is really disturbing if you really thought, oh, this was terrible, evil prejudice. Because what we're showing in these two graphs is that if you look at real world measures, like the one on the left is the dots are representing the names of jobs. And on the y-axis, the one that runs on the side there, that's showing how male or female the word embeddings think that those names are. Well, think that represent those names to be the names of those jobs. And the bottom shows how many women, what proportion of the people who have those jobs are actually women. Okay, and so you see that it's a pretty good correlation. It's a 90% correlation, which is incredible. And that's despite the fact that this stuff only works for a single word. So some of these things, like it was domestic engineer, and we threw away domestic, right? So that's just incredible that we got the 90% correlation. And you see the same thing for names like Sandy or Alex that belong to two different, that could either male or female. And that was an 84% correlation with the 1990 census, which was the last time we could find. So you could think of this as a prediction. My prediction is we'd be at 99% if we could get 2015 years there. So yeah, the hurry is just that I think this whole system's going to shut off in 8 minutes, so I better get going. So one of the things we did in the paper say, look, bias is just, in machine learning, when we say bias, we just mean regularities we detected about the world. So if that's not a big deal. The big deal is the stereotype. And we suggest that because of that last slide I just showed you, that some biases are based on regularities we don't want to exist anymore. It is just true that there were more women that were staying home and there were more men that had jobs. That's, the 1950s reality. And now we've decided that that shouldn't be happening. So prejudice is acting on that stereotype. It's not bad to know something that used to be true. It's bad to try to keep it the same way, all right? And so, for example, the thing about programmer, the bias is just knowing what programmer means at all, right? Just having that representation of how it's used in language. Stereotype is the specific part that we've decided we don't want anymore, that programmers need to be male, and it'll be prejudiced if you actually hire only males, right? So it's not a bad thing to have this knowledge in your head, it's a bad thing to act on it. All right, so the big implication of this is that the stereotypes are culturally determined, which would indicate that there's no simple algorithmic way to figure it out. A lot of people thought that unfairness and evilness is something we should be able to learn with computers, or computers should protect us against. But it's not. It's something that, there was something that we chose. It's something we chose and agreed that we don't want. And so there's no way like this, there's no simple way to pick that out from the culture. Now that's what we believe. There are people that have another suggestion. These guys, Bulak-Bazi et al., they spent like 5 years just trying to get rid of the sexism one. But there's so many other kinds of stereotype and prejudice, like age and all these other things. Yeah, maybe I should say, so there was a question about what if only men show up at the interviews? Well, then there's a choice. You could either say, you're gonna have to pick one of those, or you can say, oh, we need to do another call. All right, we need to go out and advertise harder. And that's something that, universities and companies are all dealing with right now. They're going out and saying, and governments, they're trying to say, we can't waste having all these wonderful women who aren't programming. But anyway, that's it. Let me keep going on the talk. All right, so how should we address machine implicit bias? Our suggestion is not that you spend 5 years trying to figure out how to warp the semantic representation. And in fact, do you want some company or some government to decide what is fair? Surely it's something we should decide as a group. So I think the right thing to do is, this slide is slightly out of order. I should have had this much earlier when I was talking about intelligence in a way. But I know why I'm talking about this. I'm actually here to talk about consciousness. That humans, one of the things that we have is consciousness. And so what I'm suggesting here is that the implicit bias and implicit knowledge is stuff that we've just aggregated just by looking at stuff, right? So that's sort of how our brain works automatically. But the explicit knowledge is stuff that we can learn from just one shot. Like right now, you're forming explicit memories. And you're not going to keep those forever, but hopefully you'll eventually compile these in together with your implicit knowledge and come up with a good idea. However, you might remember, oh, if I only have male people apply for a job, I need to try to figure out how to re-advertise it. You might remember one of these rules and then go and try to do something different. And so I'm suggesting, in fact, our paper suggested that, even though this sounds scary because it's associated with consciousness, you can build architecturally things like this. And in fact, one example of that is what do you call it? When predictive typing text, when it's predicting what word and trying to help you when you're typing in on your iPhone or any other phone. It's not going to guess that you're going to say a bad word, right? So there's a implicit knowledge. It's just the entire dictionary. And then explicit knowledge is, okay, there's a list of words you're not going to guess. All right, in that case. Yeah, autocomplete. Thank you, Mike. So autocomplete, you can have a short list of things that you're just not going to do. So it's pretty easy to build 2 different representations into your meeting. Okay, so this doesn't mean that AI is human just because you're able to do this. Yeah, that's what the thing that those other guys have done. Somebody's asking about tweaking. That's what those guys did, but I don't think you can get all knowledge that way. All right, so ethics is the way that society defines itself, and AI and ethics are both authored. So our authorship, I would believe that, you know, the A in AI is artifact. It's something that we've built, and we're the ones who are responsible for it. So I don't buy the people that are saying, let's build the other machines. I'm worried because we're running short on time. So I'm going to go really fast through this stuff, and you guys can go back and watch the video and slow it down. Sorry about this. Because I know there's a few slides towards the end of the summary, and I want to get to those. Sorry. All right. Yeah, this is pretty good. Artificial and natural intelligence are continuous neutral with each other. Neutral magic fairies of mathematical purity are not going to fix our problems. Sorry. It has to be biased because computation takes time, space, and energy. So we exploit the work already done by nature. Human culture contains traces of our history, including our prejudices. And so we need to design our systems modularly too, so that we can explicitly correct the things that need debugging. All right. Yeah, and I didn't talk too much about this thing about people who want to make humans. But I just want to show really fast in the last 2 minutes this. All right. This isn't all there is to bias. People tend to think that there's a bunch of bias because of lack of diversity or the stuff that I just showed you, absorbing it automatically from culture. But don't forget, AI is something you build. And a lot of the bias is stuff that people deliberately put into it. Like they're trying to change, you know, who gets welfare payments or something. So it's important to remember that there's all 3 sources of those. The automatic one, we should compensate by design. The ignorant one, yes, we can keep improving it. If we catch that we've just made a mistake because we were stupid and we didn't have people from other races on our design team, well, then let's fix that. But the deliberate one can only be fixed by auditing. And so I just want to say, don't be afraid of regulation. It happens to everybody, right? It just means that we've caught up to the present. Okay, so in the last minute, I'm trying to understand this question. Since society is biased, the data we use to train AI is also biased. Yes, exactly, you're right. AI seeks statistical truth, and statistical truth can be uncomfortable. Well, it's not just it's uncomfortable. Like I said, we can choose as a society that we want to pick a new target and go towards that. So it's important that you have recent explicit knowledge as well as statistical truth, if that makes sense. Thanks to you, all the people that typed at me, so I had some idea of what was going on. All right, that was exciting.